Good day. We are the Group 6 from CE1A, and today we will discuss our research entitled Effectiveness of Alternative Hollow Blocks or Other Materials. Before we start, let me introduce you first to the members of our group. First is Mendoza Mark Leonard S. Second is Labayuga Joseph Kevin Dave I. Third is Corsona Blair Kayla D. And fourth is Ramirez John Lloyd S. And lastly, Villanueva Lordwin P.
For the starter, I am now discussing the abstract of the study, which describes a summary of our whole research. Our research title is Effectiveness of Alternative Hollow Blocks or Other Material. To build infrastructure, there are materials that are needed, especially for the foundation or formation of it. The hollow block is a concrete material that is needed in building construction. Hollow blocks should be strong and durable in order to stand and build infrastructure. One of the alternative hollow block is from coconut because of its shell that has a lot of fiber that can be mixed with cement. In this project, the researchers came up with an idea on how to use the coconut shell after the content of it was used. The researchers aimed to prove that the coconut shell can be an alternative hollow block because of its rich fiber that when mixed with cement can reach the same standard size of 100 by 400 by 800 of a regular concrete hollow block. The power that the coconut hollow block can hold a maximum capacity and has been already tested for 28 days, and the result shows that it was reached the aging requirement of a hollow block. It is also recommended because this can be reusable and waste-friendly with a good performance.
Introduction. Concrete hollow blocks are widely used in the construction industry. It is necessary to build strong infrastructures. Concrete hollow blocks are used in different ways. They can be used for load-bearing walls, interior walls, panel walls, retaining walls, and compound walls. Finding an alternative for hollow blocks, or the material used in making them, is worth studying because the material used in today's hollow blocks can harm the environment. According to the Philippine Statistics Authority, the coconut production from April to June 2021 grew to 3.29 million metric tons, or an increase of 0.8% from the 3.26 million metric tons in the same quarter of the year. The Philippines, being a tropical country, is one of the world's largest producers of coconut products. Coconut is known as the tree of life because of its various usage and versatility. The coconut can be used in different food forms for fiber, fruit, milk, oil, and water. The waste coming from the coconut industry is approximately 6 tons annually coming from the coconut trees in the Philippines, estimated at around 500 million trees, producing a very large amount of waste every year. The availability of suitable materials led the researchers that made this study the thought on how can coconut shells be an alternative for aggregates. The researchers made this study to explore the use of coconut shells and fibers as an aggregate, analyze the performance and the effectiveness of the coconut shells and fibers as aggregates in concrete hollow blocks in terms of physical properties like color, texture, size, and density, by mechanical properties like compressive strength, modulus of elasticity, absorption, thermal conductivity, and fire resistance to obtain a design technical specification of concrete hollow blocks. In preparation, engineers should possess a comprehensive and detailed knowledge of the qualities and characteristics of these various materials to be used and the practical limits in which the quantities necessary for the work questions should be restricted.
The materials. Materials are commercial concrete hollow blocks and hollow blocks with coconut shell and fiber. We don't have a lot of materials because our research is all about physical properties. So next is the methodology. Our methodology is the coconut shells and fibers were collected and went to the drying process before discarding the foreign materials in the coconut. The coconut shell powder was prepared screening dry coconut shells and fibers. Coconut shells were crushed and stripped of the fiber before screening to properly analyze its physical properties. The aggregated product was made into a 100 mm times 400 mm times 800 mm size concrete of hollow block sample. The data sample of the product's compressive absorption, thermal conductivity, and the modulus of elasticity and rupture tests were done and obtained for curing the specimen. The product design was done after ensuring that the research end product is complete.
Good day, everyone. Today I'm going to discuss the result and discussion of our research. Physical properties of concrete hollow blocks. In Table 1, shows the physical properties of commercial concrete hollow blocks and concrete hollow blocks made with coconut shells and fiber. Concrete hollow blocks with coconut shell and fiber is more dark in color than the commercial concrete hollow blocks. Concrete hollow blocks with coconut shells and fiber has the density of 1,213.59 kg per meter cube, while commercial concrete hollow blocks density is 1,529 kg per meter cube. The comprehensive strength test of commercial concrete hollow blocks and concrete hollow blocks with coconut shell and fiber. In table 2, shown that the overall power of concrete hollow block with coconut shell run in a series of tests in day 7, 14, and 28 of testing concrete hollow blocks with coconut shell reach a load capacity of 32.43 kN to 43.5 kN, 48.02 kN to 60.25 kN, and 65 kN to 84.99 kN, respectively. The stress capacity in day 7, 14, and 28 are 1.67 megapascal to 2.11 megapascal, 2.33 megapascal to 2.92 megapascal, and 3.16 megapascal to 4.13 megapascal. In comparison with Figure 3, which represent the commercial concrete hollow blocks, in day 7, 14, and 28 of testing, the commercial concrete hollow blocks reach a load capacity of 11.65 kN to 17.58 kN, 14.71 kN to 20.24 kN, and 25.09 kN to 27.07 kN, respectively. The stress capacity of commercial concrete hollow blocks in day 7, 14, and 28 are 0.57 megapascal to 0.8 megapascal, 0.71 megapascal to 0.98 megapascal, and 1.22 megapascal to 1.31 megapascal. Both commercial concrete hollow blocks and concrete hollow blocks with coconut shell and fiber meet the required aging number. In Table 3 and Figure 4, shows that the average modulus elasticity of concrete hollow blocks with coconut shells and fiber for the 7th, 14th, and 28th day of testing are 1,400 megapascal, 1,927.5 megapascal, and 2,740 megapascal, respectively. On the other hand, commercial concrete hollow blocks for 7th, 14th, and 28th day of testing, the average modulus of elasticity are 525 megapascal, 602.5 megapascal, and 905 megapascal. Concrete hollow blocks with coconut shell and fiber has a significant modulus of elasticity compared to commercial concrete hollow blocks. In Table 4 and Figure 5 shows that the average modulus of rupture of concrete hollow blocks with coconut shell and fiber On the 7th, 14th, and 28th day of trials are 0.39 0.398 megapascal, 0.54 megapascal, and 0.40 megapascal respectively. The table 5 shows that the concrete hollow blocks with coconut shell and fiber has less moisture content and less absorbent than commercial concrete hollow blocks. In table 6, the concrete hollow blocks with coconut shells and fiber has a significantly large value of load in colder temperature. In colder temperature, concrete hollow blocks with coconut shells and fiber has a load capacity of 96.69 kilonewton and stress capacity of 4.69 megapascal. Concrete hollow blocks with coconut shells and fiber has a high resistance with high temperature condition. In warmer temperature, concrete hollow blocks with coconut shells and fiber has a load capacity of 50.47 kilonewton and stress capacity of 2.97 megapascal. And table 8 shows that the concrete hollow blocks with coconut shell and fiber can withstand high degree of temperature for a good amount of time. Concrete hollow blocks with coconut shell and fibers can withstand and find on sorry can withstand and on the 28th day of testing it has an average load capacity of 64.15 kilonewton and 3.175 megapascal. It's the average modulus is the average stress capacity. And that's all and that is the all results and discussion of our research. Thank you.
Conclusion. The data gathered shows that the CHB, or the commercial concrete hollow blocks with dimensions 100 by 400 by 800 mm, have a higher axial compressive strength than the coconut-made materials. Regardless of its disadvantage, the coconut shell-made hollow block reached the minimum requirement for an alternative hollow block. The coconut shell-made hollow block is a bit darker when it comes to color, but they have the same size. The power load and the maximum stress capacity of coconut shells has been tested for 28 days. The result shows that the number of aging requirements was reached. All in all, the study shows the suitability of reusing coconut powdered shells and other materials as alternative hollow blocks. Recommendations. These recommendations are highly encouraged for future researchers. The use of powdered coconut shells and fibers for their remarkable strength achieves the best results. It is also recommended to consider the addition of known materials to produce mixture as an alternative hollow block. With these materials, the pool of alternative hollow blocks will also increase.
So that's the end of our discussion. Thank you for listening.